Hi everyone. As we start today's Zoom lesson, I'm going to do a short review based on questions that you have. So if you have anything in particular you would like me to review, that's what I'll go over. I'll also be asking you to complete a review packet that will give you some sample questions similar to what you'll see on the quiz. Thursday morning, I know we meet first period, but I'm going to be available for a short Zoom session. If anybody would like to have a review, that would be the time to join me. The quiz will also be on Thursday, and it must be completed and submitted by 3 p.m. We'll talk more about that in our session today. So bring your questions, we'll review. Our new lesson will be on solving linear equations. We talked about simplifying expressions, we talked about our properties, we went over translations, and now we did some combining like terms and distribution, so we're ready to solve equations. Now, up until this point, it's only been expressions. Now we're talking about equations, which are a statement in which two expressions are equivalent. They have to be equal on both sides. So we're going to use our properties of quality. We're going to use these inverse operations. Whatever we do on one side, we do on other. That keeps the balance. That's our addition and subtraction, multiplication and division properties of equality. And then our goal is to solve or isolate a variable. Well, that number that we get is going to be the solution to the equation. So any number is a solution of an equation if, when placed back into the equation, it makes the statement true. To solve equations with a variable on one side, simply use an inverse operation. Let's look at some simple one-step equations. I see 6 times x equals 24. If I see multiplication, my inverse will be division. I will divide on both sides to keep the equality, and x is equal to 4. In this case, I will subtract 5. If I see add, I'll subtract. X will be equal to 16. Not giving you anything too challenging just yet. I'll do the inverse. I'll add 9 to both sides, and x is equal to 21. This is a division. X divided by 3 equals 12. Inverse operation tells me to multiply both sides by 3. And I get x is equal to 36. How do I know I have the right answers? I can plug them back in and do the check. If the two sides are equal, then I know I've done it correctly. I could also be including some negative numbers. I could have negative 5x is equal to 35 by dividing both sides by a negative 5. I get x is equal to negative 7. We want to watch our signs at all times. I could have x plus 4 is equal to negative 10. In this case, I'm going to subtract 4 on both sides. And then remember, the rules of subtraction are to add the opposite. And I get negative 14. And when it comes to problems like this, I really do want to do the check, because did I get my sign right? Was it supposed to be negative? Should it be positive? I will place this in and do the check. To do a check, it's a substitution. Negative 14 plus 4. What does that equal? Well, when the signs are unlike, I subtract. If I subtract 4 from 14, I get 10. Keep the sign of the greater absolute value. It checks. That's our one steps. And again, they can get a little harder if the numbers are higher or the signs are unlike, but for the most part, straightforward. We then go to the two steps. With a two-step equation, I might have to do 2 inverse operations, or I might combine like terms first and then 1 inverse operation. Let's look at some examples. 4x plus 1. Well, step 1 says let's undo this by subtracting 1 on both sides. That leaves me with 4x is equal to 12. Now we have a multiplication. Let's divide on both sides. I get x is equal to 3. I won't ask all the time, but I am, for these introductory, going to be doing a check. Well, I have 4. I'm going to replace 3 in there. I'm going to evaluate it at 3. Plus 1 equals 13. I have 12 plus 1. And if the two sides balance or are equal, then I have a check. Second problem. Add 3 to both sides. 5x is equal to 20. Divide by, whoops, I didn't mean that. Let's divide by 5. And x is equal to 4. Is that the right solution? Well, 5 times 4 minus 3. 20 minus 3. Subtract, and I see the two sides are equal. The last one is a combined like terms. 8x minus 1x gives me 7x. You're starting to see why I went over a lesson on combining like terms before doing this section. Divide by 7, x is equal to 4. Here, once again, let's do the check. 8 times 4 minus 4. Does it equal 28? Well, that's 32. 32 minus 4 gives me the 28. Like I said, it might be more obvious when the numbers work like this, but if there are negatives involved, that's probably when you want to be sure to do a check. Multi-step equations. Multi-step equations might include that distribution that we spent time on last lesson. I'm going to first simplify this by eliminating the parentheses. 2 times x is 2x, 2 times negative 3 is minus 6, and I have 8. I've simplified it one step. Again, multi-step, several things to do. Step 1, eliminate the parentheses. Now it's a two-step. Let's add 6 to both sides. Let's divide by 2. I get x is equal to 7. Once again, I can plug that in. 7 minus 3 is 4. 4 times 2 is 8. It works. Let's distribute one more. 2 times 2x is 4x. 2 times 1 is 2. Now we're up to 2 inverse operations. Let's subtract. And again, these introductory problems are not challenging. I just want to refresh your memory on the steps first before we do more involved problems. 2 times 2 is 4. 4 plus 1 is 5. 5 times 2 is 10. It checks. There is another type of equation that has variables on both sides. I'm going to save that one for our next session. So until our Zoom lesson, have a good morning, and I'll talk to you soon.